Hear that? That's a second. Or is it? How do we know what a second really is? Here's someone who should know. Steve Jefferts.
I'm a staff physicist at the National Institute of Standards and Technology, NIST, in Boulder, Colorado.
He's also an expert on how we measure time.
Nature provides a bunch of clocks, if you will, automatically.
For example, the sun rising and setting marks a day. The moon waxing and waning marks a month. In the past, we measured time using these natural clocks. But then we adopted more sophisticated technology.
Whether it's a water drip clock or a pendulum clock or finally a quartz crystal oscillator.
All these clocks have one thing in common. They measure periodic events. How long it takes for, say, a pendulum to swing back and forth, or the Earth to move around the sun. And today, we're using this same idea to build something even more accurate.
Now, if you want to talk about atomic clocks, we just, in some sense, go the next step.
Atomic clocks are clocks that measure the oscillations of atoms. This is pretty complicated stuff, but the basic idea is that all atoms of a given element vibrate or tick the same number of times per second.
Cesium, for example, is at 9 billion ticks in a second.
9,192,631,770 to be exact. And that number is pretty important, since today, the international standard for what a second is based on that many vibrations or ticks of a cesium atom. Part of Jefferts' job is to make sure that time in the US is calibrated to those ticks.
I simply count how many ticks the cesium atom says have gone by, and when I reach this 9 billion number, that's 1 second.
Unlike a normal clock, which might lose or gain a second, commercial atomic clocks are accurate to something like 1 second in 3 million years. And to calibrate US time, Jefferts uses a cesium clock at NIST that is accurate to a second in almost 100 million years.
If you'd had two of these clocks in the Dark Ages and you kept them ticking until now, they'd be within a microsecond of each other. And a microsecond is so small that you just don't care.
But why should we care about atomic clocks at all? Why do we need clocks this accurate?
If you don't have atomic clocks, a whole bunch of things that we do every day don't work. Lots of the high-speed protocols for data transmission on the internet go away. The GPS navigational system all goes away. Cell phone towers probably quit working pretty quickly.
Even the electric grid would stop working. Grandma! Our high-speed, interconnected world works because we can synchronize different pieces of technology using accurate time. And Jefferts says, whenever we build a better clock, engineers find some new way to use it.
Sort of a field of dreams analogy.
If you build it, the technology will come. So in the future, who knows where better atomic clocks might lead us? Only time will tell.